Now let's talk about power. Power is the rate at which the energy is transferred. We have talked about energy, we have talked about forces, but we haven't really talked about how long does it take something to do the work or for the energy to be dissipated. That all comes under power. So if an external force is applied to an object and work is done by the presence of this force in the time interval, let's say 3 seconds or 5 seconds, the average power during this interval is defined as the work done divided by the time it takes to do the work. So let's look at cars, right? So we all drive cars. What is horsepower? Horsepower is the amount of time that the car will take to go from 0 to 55 seconds. The sports cars generally do this in less than 3 seconds. Olden cars or normal cars, the ones that normal, average person drives, does it in about 6 to 10 seconds. So the power that the sports car uses and also the sports car has is a lot more because it does the same amount of work going from 0 to 55 miles an hour in less amount of time. So the unit of power is called the watt. Watt, by definition, is the energy that something has or the work that something does divided by the time that it takes to do that work. And if you were to use it in SI units, it's going to be 1 kilogram meter squared per second squared per second. The common unit for power is horsepower. Usually cars and machines of that sort always use answers in horsepower. 1 horsepower is about equals to 550 feet per pound seconds or 746 watt. The unit of energy that appears on your household electricity bill is defined in terms of power. So in that case, you will use the word that's kilowatt hour, which basically means is 1,000 watts that are used per hour, or 3.6 times 10 to the 6 joules. Instantaneous power is defined as delta W over delta T, which means the small interval, amount of work done in an infinitesimal time interval. Another way of expressing power is given here. So if you were to take power as the change in work divided by the change in time, work is force times displacement. Force is a constant, so that means delta S is the displacement is what is changing, divided by delta T. So delta S over delta T, which is what? The change in distance over change in time is the velocity. So power can also be in terms of force and velocity. So now let's do an example. A race car with mass of 500 kilogram completes a quarter mile race in a time of 4.2 seconds starting from rest. The car's final speed is 125 meters per second. What is the engine's average power output? Neglect friction and air resistance. Okay, so here the race car mass is given, and that mass is equals to 500 kilograms. And the distance that it travels is given as 402 meters. The time that it takes to complete that distance is 4.2 seconds. And it starts from rest, so its initial velocity is 0 meters per second. And it says that its final velocity or final speed is 125 meters per second. And we are required to find average power. We know about power that power is change in work divided by the change in time, which also means it is a change in energy per change in time. And we know that there are 2 kinds of mechanical energies that we are most concerned with. One is the kinetic energy, and the other one is the potential energy, divided by delta T, right? Now let's talk about this. So for potential energy, something has to be happening. So you have to either make the car rise up in height, or you have to do like some kind of a spring stretching. Since none of that is going on, the race car is basically on a level road going around in a circle or maybe not in a circle, in a straight line. But potential energy is not changing, right? So this goes to 0. What do we now know? That the average power is now going to be the change in kinetic energy divided by the change in time. Change in kinetic energy means kinetic energy final minus kinetic energy initial divided by delta t. So it tells us that the time that it takes for the car to do this is 4.2 seconds. Kinetic energy final is going to be given by 1/2 mv final squared minus 1/2 mv initial squared divided by delta t. If I was to compact it all together, my P average will be given by 1/2 m vf squared minus vi squared, initial velocity, divided by delta t. Initial velocity equals 0. Vf they give as 125, mass is given as 500, and delta t is given by 4.0. I plug all of those values in and calculate my P average. And my P average should be in watts. Go ahead, plug it into your calculator, and come up with an answer. My answer comes out to be 9.3 times 10 to the 5 watts. And the unit for power is watts. So what we've learned is power is the rate of energy transfer. Average power is given by delta E over delta T, and instantaneous power is given by FV cosine of theta. And the reason why we are putting in cosine of theta is the fact that F and V may not be always parallel to each other. The unit of power is a watt, and 1 watt equals 1 joules per second, or also written as 1 W.